Hallo allerseits. Hi everyone. I'm very happy you're here. Very happy we again have an event together with VMware regarding RabbitMQ today, Beyond the Rabbit Hole.
It's great to be here again. We have been here already back in December, but today's topic, as we asked you for the feedback, is about RabbitMQ. So what you can expect today is following topics we will be covering. For once, I'll do the welcome and set the scene of the topic itself. I'll then hand over to Vlad, to my colleague. You will see him in a minute. We will explore not only what's new in RabbitMQ, so what's happening with the product. We will look into the different deployment options and also the different protocols. So we'll even touch the question of when to use streaming versus messaging. One critical element we always hear from the customers when using RabbitMQ is monitoring. So what can you do to make sure your RabbitMQ instances are up and running? You make sure everything works, and how to can predict errors, look into the things to make sure the system doesn't go down. Later we will talk as well about advanced features. So what do we think of HA, DR scenarios, message compression, all the fancy stuff when it comes to use RabbitMQ in a larger and at enterprise scale. We will have an outlook into the roadmap, so what's going to happen next with RabbitMQ, what you can expect. And I think then we come to the fun part, which is pizza, beer, and some Dart. We're going to love to have some further chats, so we'll be definitely around to have questions answered. Happy to be here. I already mentioned that we've been here last year. We've been working with Malte to actually show some news and what we do in the CNCF landscape, what contributions we do, what projects do we work on. And we decided to make like a beautiful ending of the last year, 2022, and we're hosting the last Backstage session there. So Backstage, if you don't know and if you've missed it, is a developer portal framework which you can use to build your central developer portal for onboarding purposes, for visualizing build pipelines, learning center, whatever is needed to actually at the end speed up the developer experience and ultimately tackle the challenge of how can a new developer can easily find its way into the organization and start contributing coding as soon as possible. So in case you missed it, here's the link to it. There is even a recording. Feel free to watch it or even get back to us and still if you have some questions. As part of that meetup, we also made a survey. We asked you, it's like on the feedback, how did you like it? Should we come back or not? At least no one choose the option, you guys suck. But we also asked you, like, what are you interested to see? What could we bring up in the next meetup? And one of the two topics is RabbitMQ. That's why we're here today. So based on your interest and your feedback, that's why we chosen RabbitMQ. I'll do two slides on the question you probably raise, like why VMware? Why is VMware even here today? Just to explain the backgrounds of it, VMware made strategic decisions back in 2018 already, where we acquired a lot of organizations in the sense of modernizing of applications and providing applications and platforms that actually can host such applications. So there is, for example, Heptio as an organization where two of the co-founders of Kubernetes were working on consulting services, how to bring Kubernetes into the enterprise environments. What do we need to do for that? Another large one is Pivotal. Pivotal is known for many, many decades already on how to do modern application development. What do we need to do? How should organization look like? And that's also something which came into VMware. all these acquisitions were then formed together under the brand of VMware Tanzu. So whenever you see the logo I have on my breast today on my shirt, that's VMware Tanzu, and it all belongs and brings all the things together you actually need to build, run, and manage modern applications. Now, as the CNCF community is around open source, we also want to highlight what we do as VMware in the open source space. So probably you would connect us not as the open source contributors, more like, yeah, the other way around. But what you can see in the back is like there's so many projects you probably don't even know that VMware is either involved to a certain extent or is even like a custodian of certain projects. Like just to bring up Spring, for example, as the most popular Java framework. But also RabbitMQ today, right? We have open sourced it at some point, and we're still the main contributors when it comes to developing and bringing RabbitMQ forward. So just to sync that in, I'm sure looking at all these logos, you find some interest and say, yeah, okay, didn't know that we're to somehow involved into those projects. Now, without further ado, handing over to Vlad. I'm today your moderator for the whole session. My name is Stefan, and I'm responsible for the VMware Tanzu business within the Alps region, covering Austria and Switzerland. And for today's session, we made sure that we have an expert here on stage, which is Vlad, who is coming in from Spain today to host us and walk us through that session. Vlad, the stage is yours.
Okay, thank you very much, Stefan. Hello, everyone. Thanks for having me. I'm Vlad, and I'm a data engineer at VMware. I joined VMware last year, and I work with RabbitMQ and other VMware products. And yeah, let's talk about RabbitMQ. So we all know that we live in a world that's driven by data. Right now, we are using data to stream this conference live. We have data for our smart homes, smart devices. And like 70 years ago, the only challenge was how to store that data, how to store as much data as possible. But nowadays, the challenge is a little bit different. We have lots of storage, fast storage, and pretty much free. It's very cheap to store data. Right now, we're interested in analyzing data, visualizing it, build something with the data, and make sure our data is synchronized and available across systems, for users mostly. So that's exactly where a messaging broker comes in. RabbitMQ is the most popular, lightweight, open source messaging broker out there. And its job is to safely transfer data from one system to another, or within the same application, within the same system, to make the synchronization possible between several microservices. So RabbitMQ, like I was saying, is one of the most popular and most downloaded container images according to the Datadog container report for 2022. Some of its key features are its reliability and resiliency, its high-performance messaging with support for multiple languages and platforms, and of course it supports many communication patterns, pub/sub, point-to-point, request-reply, so on and so forth. So RabbitMQ has lots of applications, lots of use cases, and we're going to review those in the future slides. But one of the most important features of RabbitMQ is that it supports a variety of programming languages. So let's say we have Java applications that need to communicate with PHP application. RabbitMQ can be the bridge that makes the synchronization possible between those applications, but not only in this case. There are thousands, millions of cases where RabbitMQ can be used to synchronize and transfer data. So RabbitMQ is fluent in many protocols used in messaging. we talk about AMQP, Advanced Messaging Queuing Protocol, which is pretty much the standard for open source messaging. We have MQTT, which is used for IoT devices, smart homes, smart vehicles, energy, healthcare, so on and so forth. We have the STOMP protocol as well, which can be used, for instance, to connect very old legacy applications with RabbitMQ, with newer applications through RabbitMQ. We have JMS, streams, and even HTTPS and WebSockets, which is not really asynchronous communications, what RabbitMQ does, but RabbitMQ can do those as well. The interesting part about RabbitMQ is that those protocols are interoperable. So not only do we have a variety of protocols that can be used to communicate systems, but we can use one protocol to ingest the data and another protocol to send it to another application. RabbitMQ is a multi-platform solution, so we can run it anywhere, available on bare metal, virtual machines. It's supported on pretty much all of the important operating systems out there, Linux, Windows, Mac OS. And of course, we have RabbitMQ on containers. Docker, Podman, Kubernetes with all its flavors, Docker Swarm, Red Hat OpenShift. All of the container-based technologies can be used to deploy RabbitMQ and make it the data transfer solution for pretty much any use case. And why do we love RabbitMQ? As developers, as application experts, we love it because it has so many features that we can use to modernize our applications. It supports multiple protocols. We saw that before, AMQP, MQTT. It's fast, but not furious, in the way that it doesn't really require too much for it to run and to make sure our data travels safely to its destination. It speaks lots of languages. And if it's properly configured, and if what we want is to never lose data, well, RabbitMQ can do that. There's a trade-off also. There's always a trade-off between keeping all data or having more performance. We're going to see that later. But RabbitMQ can make sure your data is always persistent. And it helps us save a lot of money. And I have a clear example in the future slides of how we can save money with RabbitMQ. But for the time being, let's focus on the keyword, which is application modernization. So in application modernization, there are several tasks that need to be carried to reach that goal. And RabbitMQ is just the tool that can put all of the pieces together and achieve that ultimate goal, which is application modernization. So when we're talking about application modernization, first of all, we need to talk about decoupling. So RabbitMQ is just the tool. It's the bridge that makes possible the communication between different microservices and helps us to divide one monolithic application into several microservices, which are easier to manage. So in the exact example you can see on the screen, in a typical synchronized communication, well, for some reason, the destination of our data might be unavailable. What happens then? Well, we might just lose orders, we might lose clients who lose their patients, and so on and so forth. But with RabbitMQ, that's not the case. So RabbitMQ makes sure it holds the data that's sent to whatever components of the application and makes sure it will be delivered once the other party becomes available. In an event-driven architecture, also RabbitMQ is the component that glues together all the components and makes sure the data arrives where it needs to arrive. Because it has smart routing capabilities, RabbitMQ can send the data across different systems to whoever needs to receive it. And that's how it helps us to achieve a highly scalable, resilient, and well-suited environment for our modern applications. So with using RabbitMQ publish-subscribe communication pattern, for instance, we can achieve also this goal of having an event-driven architecture. What else is also very important in reaching the application modernization? So we have scalability and load balancing. RabbitMQ is a tool that can be used as a single instance, so we can use one node only if we want. That's perfect. We're going to achieve the best performance we can. We're going to achieve a very good performance with one node, but if that's not enough, RabbitMQ can work also in a cluster. So a cluster is a group of RabbitMQ nodes that work together into achieving the load balancing and also high scalability. What if our nodes are not enough for what if our nodes are not enough for the load we are expecting? Well, we can always add more nodes. And if that's not enough, we can always add additional RabbitMQ clusters, which can distribute our data across different systems. Another feature of RabbitMQ is the possibility to replicate the data to a passive cluster. So in the first scenario, we saw how we duplicated the active cluster so we can have our load distributed. But we can also have a passive cluster, generally called a DR, disaster recovery site, where we can replicate everything that's going on in the primary clusters into a passive one, which will be ready in case a major disaster occurs. And not only that, but also RabbitMQ supports the scaling of our applications. So if there are a lot of messages in our RabbitMQ broker, the applications can be, we can run new instances of the application to consume the remaining messages. So to summarize, RabbitMQ can help us to take our data from point A to point B, C, D, E, whatever, and it's a highly scalable application that helps us with this scalability and load balancing purpose. In terms of integration and interoperability, RabbitMQ can be the perfect bridge between a legacy application and a new module that's running maybe on cloud. So we can have on-prem solutions and on-cloud solutions that can be connected and synchronized through RabbitMQ, asynchronous messaging. When we're talking about application modernization, fault tolerance and reliability are key components. So RabbitMQ makes sure it gives us the features we need to achieve this goal. Through a series of techniques and mechanisms, we can make sure that our data is never lost and it always reaches its intended destination. Publisher confirms and consumer acknowledgement. So this is used to make sure that whenever a publisher sends a message to RabbitMQ, that message is never lost. So we make sure the message arrives and we know what happened to the message. And in the case of consumer acknowledgement, RabbitMQ will make sure the message will never be removed from the broker before receiving the acknowledgement from the consumer. So that's a really powerful feature which helps us to make our data available at all times. Clustering. So clustering can be used either for load balancing or for replicating our data, making sure we achieve resilience in this case. Not only service availability, but also data availability. Clustering helps us to replicate. So in the case of clustering, we have several nodes acting as one, and the following feature is queue replication, which works also in a cluster, and not only replicates the schema, which are the objects like exchanges, queues, virtual host, but also replicates the data. So we have a cluster of 3, for instance, and one of them goes down. no issue. The other two will keep working and no data will be lost. Federation and shovel are mechanisms that can be used to synchronize RabbitMQ clusters between themselves, shoveling also to move data from one queue to another, or from one queue in a cluster to a queue in another cluster, or even within the same cluster itself. And the last feature is, well, there are a lot of them actually. These are just samples. The last one is the cluster replication. So the cluster replication is exactly what I was showing you before. RabbitMQ has the capability of replicating everything that's going on in a primary cluster into a passive cluster, which is ready to take the load if a major disaster occurs. In migration and legacy systems, system integration, RabbitMQ can be utilized as a bridge between legacy application and modern applications. So in this case, let's assume that we have an e-commerce platform that can, that's still a legacy application, on-prem, for instance. And we want to migrate step by step our users towards the new application, which is a modern one on cloud with all those new technologies available. So RabbitMQ, through its synchronization capabilities, allows us to have both of the application running at the same time, because it makes the bridge between them and makes the synchronization possible. So to summarize, RabbitMQ is a broker whose capabilities contribute to the modernization of the application. But yeah, let's review that. So we know that app modernization is a transformation process aimed at updating our applications to improve their performance, their operational efficiency, and align them to current business needs. However, through app modernization, we can also understand the process of refactoring a very old application, monolithic application, into one with microservices, container-based, and so on and so forth. So RabbitMQ offers us the capability of transferring the data and making sure that that migration can happen step by step, one step at a time. So reliability, scalability, and resilience, decoupling, containerization and orchestration, interoperability, and high availability, those are all features that are offered by RabbitMQ and so we can achieve our ultimate goal, which is app modernization. However, I was saying that the ultimate goal is app modernization. However, from my point of view, there's a step further. So having our application cloud native ready is actually the ultimate goal. So even if both app modernization and cloud native application strategy share some common goals, the ones we reviewed before, their approaches can be slightly different. It's like refurbishing an old house or building a new one. So yes, some of the tasks are the same, the goals are quite different. However, RabbitMQ is there for making this transformation process possible, not only for legacy applications toward app modernization, but also is used in a cloud native environment where application need to transfer tons of data. And how do we achieve that goal? So RabbitMQ offers the possibility to transfer the data through streams and through messages. They are not actually, that's why I said not versus, because it's not a competition. With other brokers, I don't know, I think I can say the name, right? With ActiveMQ, for instance, we don't have the support for all the protocols that RabbitMQ has. So it's a great broker, but the limitation is the number of protocols that can operate. With RabbitMQ, so let's assume that we have ActiveMQ, and later, at a later point in time, we need a messaging broker for our MQTT devices, for our IoT devices. Let's imagine a factory or something. Then we need to add a new broker for MQTT. And all of a sudden, we're going to need streaming. Then we need to add Kafka or RabbitMQ. With RabbitMQ, that's not necessary, because RabbitMQ encapsulates all those protocols within one only broker. That's why the title, a broker to rule them all. So the difference between messaging and streams is quite simple. In messaging, we want a very smart broker, and we can have a dumb consumer. In streams, we can have a dumb broker, but we need a smart consumer. Messaging is known for its routing capabilities. So if we need to send the data to several destinations, if we need to do some filtering and to have basically additional features like message expiration, message ID, correlation ID, custom headers to the message, encoding type, whatever. So if we need that, we need to use messaging. However, if we don't really care for options and for features, and we want to send as much data as possible, for instance, to create a data mesh or to synchronize a data lake, that's where we use streams. Just so you can have an idea, RabbitMQ in normal conditions on messaging can transfer about 60,000 messages per second. There are techniques to achieve more than that. However, with streams, we can have up to 1 million messages per second, a little bit more than that. So the difference is huge. So this is how a messaging pattern would look like. We have in messaging in RabbitMQ, when I talk about messaging, I mean MQTT, JMS, AMQP protocols. So in AMQP, we can have different types of exchanges according to our needs. And we can have our data transferred to our queues, to our consumers, according to some filters and according to some rules. So this is exactly it. For AMQP, we have smart routing capabilities. We have plenty of features. I was telling you about the custom headers, and the properties we can attach to the message. We can have the routing rules, the routing key, which allows us to send the message only to intended destinations. We have a decent throughput, so 55,000 messages per second is a decent throughput compared to other messaging brokers. And the semantics for this protocol is simple: consume and destroy. So the idea is that in AMQP, we read the message from the queue and the message will be destroyed. We can still keep it if we want, but that's not the purpose. So AMQP has not been designed for storing messages. It's not a database. Messages just need to travel and exit. So that's one of the limitations. AMQP and messaging itself have these limitations. For instance, one of the limitations is that we don't check for the content of the message. If we're interested in the broker to do some validation based on the content of the message, that's not going to happen. So all that falls into the responsibility of the consumers. Sorry, going back to AMQP. AMQP is the general use messaging protocol. So for point-to-point communication patterns, publish, subscribe, we just need to send data to to whoever needs to receive it. I don't know, in e-commerce platforms, in CRMs, all these types of situations. Financial data can travel through AMQP. those are the use cases for the general use cases for AMQP messaging protocol. So it's the general purpose protocol, if you want to call it like that. While the MQTT is specialized in industrial applications. All those sensors, actuators, smart home devices, smart vehicles used in energy, in healthcare. In healthcare, there's a specific case I'm impressed about, those small bracelets that are used to to follow the sugar level in the blood. So some of those use the MQTT protocol to transmit the data in real time. Why is that important? Why is it important to use a messaging protocol? Because we can, in that case, we could think we can use HTTPS or whatever synchronous protocol to send the data. Well, in some situation, the device might lose the connection, okay? And what happens then? Our data will be lost. In these types of sensitive situations, we want to keep the data even if it arrives a little bit late, because we want to have the historic data available. So that's exactly one of the use cases for RabbitMQ. RabbitMQ is also used on, or messaging protocols, generally speaking. Asynchronous communications are used also on platforms that are on the sea, from petrol platforms, okay? Those platforms have really poor communication. Some of the data might not be able to be transmitted in real time. It just stays there and it's sent whenever the consumer becomes available. So asynchronous communication is the perfect use case for these situations. So now that we talked about how important it is to have our data available at all time, and we're using a good, very good, I would say the best broker out there. How do we make sure our broker is always up and running? So the RabbitMQ community has designed a monitoring system which is free, based on Prometheus and Grafana. No effort, no cost to implement it, and everything is already done. Just implement it. But there are also other options. Some of them cost some money, others are free. There's VMware ARIA operations for application, Zabbix, AWS CloudWatch. Datadog has done a very good job with their RabbitMQ templates. Dynatrace, Splunk, Tanzu, Sentry. Lots of options. RabbitMQ is popular, and a lot of people have done a good job implementing RabbitMQ templates into their monitoring systems. Let me show a sample of how much data can RabbitMQ handle. This is a situation, a test I've done on a local machine, local developer machine, sending several hundred thousand messages per second through a normal RabbitMQ based on a local dev machine situation. Okay, almost 1 million messages per second are sent. RabbitMQ is behaving as if nothing happened. Have millions of messages in the queue, which are published and consumed at the same time, and in the Grafana dashboard, we can see how those messages travel. So this is what we see in the Grafana dashboard that comes built in with RabbitMQ. Several hundred thousand messages per second. There are a lot of useful charts that we have in the monitoring system. And not only this, but we also have the RabbitMQ overview, where we can see a general situation, a general status of the RabbitMQ cluster, how many messages are available, how many publishers and consumers we have, a lot of useful information so we can have an idea of what's going on in our RabbitMQ cluster, but generally speaking in our system, because we also need to take into consideration network, storage, all that. So, like I was saying, This has been going on for a few minutes already, and it can go on forever. This is a huge load. Like I was saying, almost 1 million messages per second. And RabbitMQ can take it, no issue. Going back to the Grafana dashboard, so I was saying we have a lot of interesting information we have in the charts, which can be very useful when trying to troubleshoot a situation, an incident, whatever. And on top of that, we also have the Erlang memory allocators, which could not say much to the general public, but to RabbitMQ experts, engineers, who are probably troubleshooting an issue that happened in the past or is happening at a certain point in time. That's information that can be very useful. Yeah, and that's pretty much it for this. So we were talking about monitoring. What do we monitor to keep RabbitMQ rolling? The general impression is that we need to monitor our queues. All applications want to monitor the queues because they want to know how many messages they have in the queues and how many consumers. They want all the queue metrics. And that's not such a bad idea if you have 500 queues, 700 queues. However, if you have an environment that has tens of thousands of queues, that's going to be an issue. Because interrogating RabbitMQ all the time for that metrics can be highly inefficient, and I don't think we're going to reach our goals. So a smart strategy in this situation would be to configure our queues with dead letter queues. Dead letter queues are normal queues that are attached to the main queue. So in case messages cannot be sent to their intended destination, they would be forwarded to the dead letter queues. And that's what we need to monitor. So for instance, we can have a dead letter queue for a group of applications. We can put a limit to our primary queues and say, look, if you receive more than 1 million messages, stop receiving them and send them to the dead letter queue. And when messages begin arriving to the dead letter queue, that's a signal that something is going on. So instead, my point is that instead of monitoring tens of thousands of queue, we can only monitor one. Because if that dead letter queue, that's like the recycle bin, okay? If that dead letter queue has a message, there's something going on and we need to check. If it has more messages, it definitely needs human intervention. Another thing that we monitor is the resource consumption. So in the case of resource consumption, we want to make good use of the newest technologies out there, containers. We can have our container-based technology like Kubernetes configured in such a way that when RabbitMQ pods reach 80% of CPU or RAM or whatever, just bring up a new pod and scale that cluster. That can be automated. And that's why RabbitMQ is so powerful combined with new technologies. Like I said, Kubernetes, OpenShift, whatever. Because it can scale up and it has an auto-discovery peer mechanisms that integrate new nodes into the cluster to equally distribute the load. File descriptors, that's highly important because if we remain out of file descriptors, we're not going to be able to do any more connections to RabbitMQ. So file descriptors need to be set at the beginning and need to be observed along the way because that can be a game changer. Also, RabbitMQ has integrated alarms. So the alarms can be recovered through the metrics, through the RabbitMQ CTL CLI, also through the HTTP API. So there's a section in those metrics where you see alarms, and RabbitMQ is going to say loud and clear what's going on. The most encountered case where alarms are useful is when a node goes off. Maybe it's a network split, maybe something is going on that node. All RabbitMQ nodes will report that there's an alarm, something is going on. But alarms can also be triggered for other situations. Disk usage and speed. So until quorum queues, which is a high availability features of RabbitMQ, we would have the possibility to store our messages, our data into memory or persist it into disk. Since quorum queues and streams also, all messages is persisted to disk. So the future of high availability solutions in RabbitMQ is having all the data written to disk. That means we are going to need fast disks, fast and reliable ones. So we want to make sure we have enough space on disk and we have the best disk, the best performant disk we can get. And if you ask me, I would say go for the fastest. In a cloud environment, go for the ultra performant SSD, the most performant you can get. Cluster status, another thing we want to monitor, but in this case, what we want to see is that the nodes are up and running. So we have a cluster of 5 nodes. With the cluster status, we want to make sure that all nodes are there. So we need to monitor that. And last but not least, end-to-end monitoring. This doesn't come, this is not actually built in, but we can build it. It's as simple as creating a publisher and creating a consumer. We want to send a message every 5 seconds, 15 seconds, I don't care. But we want to see that the messages we send arrive to their destination. If they don't arrive, there might be an issue. And if the timestamp is larger than, I don't know, 10 seconds, that's also a hint there's something going on in between. It might not be the RabbitMQ, but it's very useful to do that type of periodic tests so to see how's our broker behaving. So what's new in RabbitMQ? There are some pretty exciting upgrades. So version 3.12 has been released in June, a few days ago. We have big performance improvements. So if you're running a previous version of RabbitMQ and you want better performance for it, please upgrade. That's what all software editors say. And we have native MQTT. We've been waiting for that for years now. The advantage of native MQTT is that it's not based on AMQP. So until now, MQTT used to work on AMQP backbone. However, right now we have support for native MQTT, so you can just have an idea of how much improvement has been made. If with one MQTT connection in a previous version we had 22 Erlang processes created, right now we have only 1. That leads us to have a memory usage drop by up to 95%. So if in the past you were running a cluster for MQTT and needed 200 gigabytes of RAM, right now you're probably gonna need 1/10 of that. For the first time, RabbitMQ can handle millions of connections. So we can have a lot of devices connected to RabbitMQ, and most likely we are going to be able to reduce the number of RabbitMQ clusters we are currently using for our MQTT devices. The end-to-end latency drops by 50 to 70%, and the throughput increases by 30 to 40%. Another relatively new feature of RabbitMQ is the super streams. So we were talking before about streams. The super streams is a way of partitioning large stream into smaller streams. That's a feature that has been requested a lot by the community because Kafka has it. Now we have it as well. So if you need streams, just rely on RabbitMQ because it also can do it. Just an example of the difference between native MQTT and AMQP based one. So you can see on the chart, the red lines are with older versions of RabbitMQ. So these are 100,000 connections. So for 100,000 connection, we would need 20 multiplied by 3, so 60 gigabytes of RAM. With the new version of RabbitMQ, which is the green line over here, we only need 6 gigabytes. Same for millions of connections. In this case, this is an example of 1 million connection to RabbitMQ. We needed 300 gigabytes before, and we only need about 20 gigabytes right now. So the improvement is huge. And I think this is the last topic, VMware RabbitMQ. What's VMware RabbitMQ? We usually call it the commercial version. I personally don't really agree with that statement, because in a production environment, global scale production environment, we need a software editor to support our product, okay? So all big corporations that use even open source RabbitMQ, they acquire support from VMware, from other companies, whatever, to have their product supported in case of need. So you see a bug, and you want it to be fixed as soon as possible. If you have the support, you're going to get that. But VMware went a little bit further than that. It created 2 additional features that come in within that support price. So nothing else needs to be paid for. And make RabbitMQ a little bit more appealing. So let's imagine that we have a RabbitMQ cluster of 5 nodes, and all of those nodes need to communicate between themselves because they need to replicate the schema and the data. So we are talking about maybe gigabytes, terabytes of data that is flowing through our networks. RabbitMQ comes with VMware RabbitMQ comes with a compression plugin, and that communication, that network traffic is reduced up to 96%. So in an on-prem situation, that can be interesting because we are going to remove a lot of headaches to our colleagues from networking. But when we are on a cloud environment, that can translate into money. That's how much can we save in a cloud environment. It's just an example, 200 million messages per day, 5 queue replicas. That's only for 1 queue per month. If we have thousands of queue, those numbers can become even millions, and we've seen it. So you see the website, you can go there and simulate your savings with using VMware RabbitMQ, and yeah, that's public. The other additional feature of RabbitMQ, I was telling you before, is its capability to replicate everything to a passive cluster. So that can be achieved also with the open source version of RabbitMQ. It's a little bit trickier, and it involves a lot of work, a lot of monitoring, and a lot of people knowing exactly what they're doing at all times. However, with VMware RabbitMQ, that is integrated and ready to be used. Additionally, I was mentioning the premium support 24/7. What's coming for RabbitMQ? VMware is working on a RabbitMQ as a service offering. So that solution will come in 2 shapes. We're talking about a fully managed RabbitMQ cluster like the one in Amazon MQ. And we're talking also about bring your own cloud. In the bring your own cloud solution, you can say, look, I have my cloud here, it's a private cloud, just give me a managed RabbitMQ as a service. And we're also going to be able to do that in the future. If you want to register for the RabbitMQ as a service beta, you can have it on you can do it on the RabbitMQ website. The link is there. Another feature that's coming for RabbitMQ in the near future, well, not sure if so near, But in the future is the support for MQTT 5.0. That's not a promise, but the engineering team is working on it, and it's been published on the Google Groups discussions and also in the GitHub repository of RabbitMQ. So the intention is to support MQTT 5 because the current version supported is 3.1, which is just the general purpose MQTT version. And further into the future, RabbitMQ 4.0 is in the works. So we don't have so much public information about it, but we know for sure that we're going to get increased resiliency of the core broker. We're going to optimize the code and the configuration. We won't have RAM nodes anymore, so everything will persist on the disk. And the mirrored classic queues will be deprecated. We've been saying that a lot of times, and I take advantage of this event to remind everyone, if you are using mirrored classic queues, move to quorum queues as soon as possible, because you're going to be, the mirrored classic queues will be deprecated. Not the single classic queues, but the mirrored ones. And the last one, let's see some problems that RabbitMQ can solve, real-life problems. So RabbitMQ is used for massive data ingestion. Companies with huge throughput often struggle to efficiently manage the influx of data from multiple sources. So that's why RabbitMQ is the perfect candidate, the perfect tool to do that massive data ingestion. Asynchronous processing. Lots of use cases for asynchronous processing. We were just talking about that, that bracelet for measuring the blood sugar, the sugar in the blood. Applications with traffic spikes. If we have an application that experiences spikes in traffic, like booking websites, RabbitMQ is the tool that will keep the messages there until the processing application is ready to take them. So we won't lose bookings. Microservices communication, decoupling system components, task distribution, real-time delivery. With streams, with MQTT, we have lots of opportunities to solve a lot of issues. Resilience against failure. We were talking about all these capabilities that RabbitMQ offers to be resilient against any kind of failure. Order processing. Mostly used, it's one of the most used tools for e-commerce platforms. Amazon, eBay. IoT data management. The IoT devices, smart homes, smart vehicles, factories, automotive companies use it for their sensor actuators, for their cars, for the connected vehicle. Backend job prioritization, email queuing, log aggregation. So the thing with log aggregation, we know that when we do log aggregation, there's a lot of data traveling, and we need someone to keep that data for us and to be able to transfer huge amounts of data. That's why we have a messaging broker. Database synchronization, intermittent connectivity, multi-protocol support, real-time analysis, video streaming and location tracking. So for video streaming, for instance, when we see those Instagram videos or YouTube ones, some of them use RabbitMQ or a messaging broker for the chat in that live session. And for more real-time gaming, healthcare monitoring system, financial data, and collaboration tools. RabbitMQ is the tool which offers a variety of protocols, variety of features, and that's why it's the broker that rules them all, because it has everything integrated. That's it. Thank you very much. And if there are any questions.
Thanks a lot, Vlad. We do have questions. If it's okay for you, I'll start with the one asked in the chat online. Sure. Vlad, what are the plans if AMQP 0.9.1 Will this remain a first-class citizen in RabbitMQ, or are there changes planned with, for instance, 4.x?
Okay. So we know there's a lot of concern about AMQP 091 and AMQP 1.0. The long-term plans are to keep RabbitMQ working on AMQP 091. As far as I know, we're going to keep RabbitMQ working indefinitely on 091.
All right, thank you. I hope this answers your question, Lucas. Any other questions online or on premises?
Yeah, we have the situation that we consume a message and then we figure out we can process it right now, so we send it back with a delay to the exchange. And if I define a delay, it gets stuck in the exchange and it's not persisted. Am I right here? So if my cluster would shut down, the message would get lost because it's in the exchange and not in the queue.
When you publish a message with a delay, so the delay actually, when you set a delay that acts at the consumer level, so you have a 5 seconds delay, okay, you put a 5 seconds delay, and that message will not be published to RabbitMQ until those 5 seconds have passed. So you wouldn't say that the message is in RabbitMQ itself yet.
No, we send it back to RabbitMQ to the exchange with a delay. There is some parameter that works and the exchange keeps it there until the delay expired and then sends it to the queue to be delivered. It's not the consumer that keeps it for 5 seconds. That would be easy. That's maybe an approach we can do. But anyway, could break too.
The message, if the message is persistent, it will not be lost. So it can't be lost. But if you want, we can carefully review your case and maybe we find a solution to that. But if the message is set as persistent and everything is configured as it should, the message cannot be lost in RabbitMQ.
Okay. Good to hear.
We have Gabriele saying Vlad, so I think it's for you, Vlad.
Yeah.
Vlad, I think she's talking about the delay exchange plugin.
Okay. That's a different scenario. Well, I'll be honest, I don't have so much experience with that plugin. But yeah, like I was saying, let's review your case and we're definitely going to come up with something. And if we discover something that's interesting for the community, we're going to do a blog post about it.
Okay.
Thank you. Thanks. Any other questions, comments? War stories. I know some people here have war stories with RabbitMQ.
You want to go first?
Well, no, but I know other people who have war stories with RabbitMQ. Any war stories? Do you want to tell war stories regarding RabbitMQ? You want to?
I'm not sure if it has been fixed already, but there is a management plugin for the UI.
Yeah.
And the management plugin offers a REST API.
Uh-huh.
And there's a micro.
Yeah, I think you need to keep it close.
It's not that you're allowed to speak talking, it's a microphone.
Okay. Okay, so the management plugin offers a REST API. And I experienced cases where you can create exchanges via the REST API with invalid properties, where you have a null on a position where it is not allowed and it's not checked in the code. actually, which was quite surprising to me because Erlang as a functional and highly typed language, I would expect that this couldn't happen, but it can. And I think it was this auto-delete feature. It has to be true or false, but you could create it with null via the REST API. Then you have it in the amnesia database with null. Then when the exchange is checked, if it could be deleted, if the flag is if it's true false,
Yeah.
then you get a match exception because you don't have a function is a functional language. You don't have a function matching having null but not a boolean there, and then your RabbitMQ crashes.
Yeah. So, yeah, we've seen those in the management interface. Yeah, we've seen worse than that. But our team, the community team, is working on them. So I don't know if your specific case has been solved yet. I'm gonna have a look into it. But yeah, we've seen some of those. Mm-hmm. So we always say that the management UI is just for basic administration, basic monitoring.
But it has a documented REST API.
Yeah.
If you give a REST API to a developer.
Have you reported the bug?
I'm not sure. I think it was already an issue on GitHub, but
okay. If it's on GitHub and if it's an issue reported, it's most likely already solved. I don't know when you faced it, but they are pretty fast. Okay. I discovered a bug like 3 months ago, and in 2 weeks it was already deployed, solved.
Mm-hmm. But later, when we have beer and pizza, why don't we make a pull request?
Yeah, we can.
Let's do it in the pause.
And to everyone watching, just use the Google Groups, RabbitMQ, the Google Groups discussion, RabbitMQ dash users, to report any issue you might find. Also use the GitHub, of course, because we have our very talented colleagues. I take advantage and mention them. It's Luke, it's Michael, a lot of colleagues that are there present, and they are part of the core engineering team of RabbitMQ.
Also, a big thank you to Gabriele, who is very active in the chat. Thanks a lot. I have a question. So, is there a way, or how would you approach if I want to validate the message one way or the other? Is there any way I can do that?
The content of the message, you mean?
No, more or less the schema of the message.
Yeah, you can do that in the consumer.
Yeah, but you don't have a feature like in Kafka, right? Where you can have,
no.
I think only for the paid version, the Confluent Kafka. In Confluent Kafka, you have the possibility to use the schema registry, to validate messages against the schema registry on the broker side.
Yeah, so RabbitMQ is one of those brokers that is content agnostic. It doesn't really care what you're setting, just send the data. Okay. So no validation, it can be done from the RabbitMQ broker itself.
And there is no kind of suggested solution having like something like a schema registry where you store your schemas, which you will then validate in the consumer or producer. Is there any like good ready open source solution which?
Well, I have some in mind, but not open source. There are some third-party tools that you can use with your consumers to validate that data before, yeah. But to be honest, I don't have an open source one in mind.
Oh, okay.
But if there's a lot of interest for this from the community, maybe it can be done, who knows? It's open source, so anyone can come with proposals.
And pull request, right?
And pull request, and with solutions as well.
Yes.
Okay. So, first question. You mentioned community and community. Which communities are involved and how can someone be part of the community?
So,
Or not be part of the community, help out the community and also like getting involved.
okay. On the RabbitMQ.com website, there's a section where you can see how you can become a developer for RabbitMQ. So when we talk about the community, that's what we mean. The community of developers that work to improve and to maintain RabbitMQ as software.
So in 2 or 3 steps would be to go on the Google Groups, and from that part they will...
Yeah. No, on the Google Groups, actually, we do the conversation, the discussions. If you want to become a developer, most of the work will be done in GitHub. Mm-hmm. So, if you want, I'll show you later, RabbitMQ.com, and there's a section on how to
If
become.
it's not C++, I might.
It's Erlang.
Yeah.
I do not know if I want.
Yeah, it's Erlang.
And second question, your personal opinion. What comes to your mind without thinking too much? What does it mean, freedom with multi-cloud? Or how do you perceive freedom in the multi-cloud with...
Freedom, wow. That's a good question. When I think of multi-cloud environments, the first thing I think of is costs. Okay? So freedom is the possibility to choose not the cheapest solution, but the best balance between cost and performance.
So you mean no vendor lock-in?
Sorry?
So you're referring to not having a vendor lock-in like
Exactly.
to the Azure-specific solutions, but you don't talk here about free as free in terms of free, not free as free beer. So this would be another.
This is another discussion, yes. So also freedom can be interpreted as having all those technologies available. So maybe, I don't know, Red Hat is very good on its automation tools. AWS is very good on its virtual machines, the EC2 instances. Azure is very good in its ultra-performant disks. That's also freedom. Okay, so multi-cloud allows us to choose the best technologies for us and maybe be as cost efficient as possible.
Okay, thank you very much.
Thank you for the question.
Also, other people can answer if they have
Yeah, of course.
especially a contrary opinion.
So it's my first time doing this, so hit me as hard as you can. Not with a cube.
Well, it's a very soft cube. Yeah. I mean, RabbitMQ, you can start it anywhere, right? Instead of, if you talk about freedom, right? Instead of using the proprietary Azure service or something like that. My question here would be, is it important that the management layer, we have the management layer and we have the protocol, right? I don't know, but I think the cloud services talk different protocols. So perhaps could ingest MQTT or MQP to proprietary software as a service solutions. The question is, how important is the management layer?
The management of data.
The management layer, like, or the broker. How important is the specific broker? Sorry for that, yeah. The specific broker.
Not sure. I'm not sure I got the question, sorry.
Would you say it's easy to swap out RabbitMQ or not? Because you already have, you're already using MQTT, so would it be easy to swap out RabbitMQ if you want to or not?
In MQTT, you just need to change the IP address of the broker. That's it. As simple as that. So it's fully compatible. In JMS, for instance, you need to change some properties. Also pretty easy to. So most of the JMS applications use those bindings files. We regenerate the bindings and that's it. We forget about it. However, coming from other messaging brokers such as IBM MQ or Apache Kafka even, that can be a little bit more challenging. It really depends on the use case and we need to analyze case by case. But it's also possible. The easy way, like you said, from MQTT, yeah, straightforward. Just change the IP and that's it, the IP or DNS.
Yeah, and the other question is a curiosity, because I'm intrigued. How is it possible to be fast? How is it possible to be faster when you add more drives? So you actually moved from processing in the memory, which was the new trend, starting new trend 6 years ago, some more than 5 years ago, and now you go. How is it possible to be faster when you increase the storage?
Yeah, that's why I need.
What's the trick?
Yeah,
if it's knowable, I don't know, or something.
No, of course. That's why I said it's really important to use very performant storage, okay? But there's also a tremendous amount of work that has been put into RabbitMQ, and it evolved a lot during the latest versions. So if you check starting RabbitMQ 3.9 upwards, in all of the release notes you're gonna see performance improvements. So that's the focus of our engineering team, of the community engineering team actually. And even if 2 years ago we were using RAM for RabbitMQ as a base for storing the messages, right now we afford to use storage disks because RabbitMQ has evolved so much.
Thank you.
I was just giving the example with native MQTT. The previous version, which is still supported, and actually I think 100% of the people still use it, the version 3.11, uses MQTT based on AMQP, on an AMQP backbone. With that implementation, for each MQTT connection, we would have 22 Erlang processes created. With the current one, we only have one. So that's how much RabbitMQ has evolved from that implementation to the new implementation. And of course, if we have less resources consumed, we can afford to move to maybe less performant technology. However, the SSD drives on clouds right now are actually really performant.
What are the success stories of RabbitMQ? I, for example, know that Sentry is using it internally. Armin Ronacher was had a talk last week at Codecrafters. No, I think it was 2 weeks ago. Do you know of any other large software as a service offerings that use RabbitMQ internally?
Yes.
Who are they? What are they?
Well,
Why did they choose RabbitMQ?
I'm not even sure which I can disclose or not, but there are some of them. So RabbitMQ began with JP Morgan, so we have that for sure. We have a lot of financial institutions, lots of them, because RabbitMQ is very used in this financial field. Financial organizations like their data to be persistent and like to make sure that their data is safe. So they use RabbitMQ. We have travel agencies, Trivago. We have SoundCloud, the alternatives to Spotify. Let me think. Goldman Sachs, automotive companies, which I'm not sure if I can disclose, but then I'm not going to say. Lot of huge organizations. Not to mention the government agencies. government agencies in lots of countries, Switzerland, Spain, Germany, United States.
And do you know what are the most important reasons why they choose RabbitMQ instead of other message broker systems? Do you know that? Well, I mean, you mentioned some today, but if you could pick three, looking at the customers, what are the three top ones you say that's why they use RabbitMQ?
Well, first of all, because it's open source.
Okay.
And if they go for the commercial version, let's make it clear that it's a lot more economic than the competition. Okay, so that's another. It's the high availability features, which some brokers don't have or have at a very high cost. Okay. It's the possibility of having normal messaging and MQTT integrated into the same broker. That's one I've seen quite recently, actually last week.
What do you mean by normal messaging?
AMQP.
Oh, I see.
So they want general purpose messaging, and they also want some MQTT for their IoT devices. The fact that RabbitMQ is, like I was saying, fast but not furious. It doesn't require so many resources. It doesn't require complex architecture like zookeepers. Right.
Perfect. That's already 4. Thank you.
And you are asking why people buy it, because they have meetings with cool people like myself and my colleagues.
Of course.
And we do a very good job convincing them.
You've mentioned the compression feature in the paid version, I think. Do you have an idea of how much of a performance hit in terms of maximum throughput that you can achieve you will lose when you turn on the compression, because obviously that takes some cycles away?
Not really noticeable. If you want me to tell you a number, I cannot say a number, but you'll barely notice it.
Okay, so just test it out.
Yeah.
Any other questions or comments? Or war stories? Love stories?
I have a joke, if you want.
Yes, of course. Is it about messaging?
Yes.
Perfect.
Are you going to say better joke or?
Let's see.
Let's stop recording.
So, yeah, let's stop recording. Yeah.
No.
Yeah, you know why RabbitMQ can never be your friend? Because it never drops a message.
It's not used to be true. Oh.
And on that note, thanks a lot, Vlad. Thanks a lot, Stefan. Thanks a lot, everyone, for being here and for watching the recording, and some closing words, perhaps.
Some closing words, yes.
Yes.
Lovely. Thank you, Malte, for having us. Thank you so much, Vlad, for walking us through. Thank you so much for all the questions you raised on site and remote. We just wanted to give you a heads up that save the date. We already worked with Malte on the next meetup. We're going to be here in September around the topic of build packs. So how can you build container images very efficiently without worrying about writing curious Docker files and all that stuff? How can you use something like build packs? Maybe look it up if you're interested. Save the date. We're going to for sure share more information soon. Also want to say thank you to NTS, who are hosting us today, are the location sponsor for this event. What's going to be following next is, where's my nice fancy rabbit? It's here. We're going to invite you for, like I said before, beer, pizza, and some Dart. So stay tuned, stay here with us. We're open for feedback, so if you could give us just thumbs up, thumb down, what you're missing, what we can do better, what you want to see next time. And also our contact details, obviously just reach out to us if you want to know more, if you want to discuss any specific cases. But like we said before, happy to do that right after with some drinks. And thank you so much for being with us. Thanks.